Rahul, thanks so much for joining me here on the podcast today.
Yeah, thank you so much, Ari. Thank you for having me. Happy to be here.
Yeah, it's my pleasure. So before we talk a little bit about the Connext protocol, do you want to just share for 2 minutes your role at Connext?
Yeah, sure. So I'm one of the co-founders of Connext. So I've been in the space since about 2017. Got in this space early on while I was still living in San Francisco. And then I ended up kind of networking around Ethereum developers. And I met Arjun, who is one of the founders of Connext. And we kind of like hit it off around some ideas, jammed out on a few things. And then we just decided to jump in and start Connext together. And 6 years later, here we are. So been a journey.
Great. Yeah, I mean, Connext I think it has a little bit of a different lifespan compared to your other DeFi other protocols overall. I know you guys have been trying to solve different problems along the way. But I guess before we talk a little bit about Connext, I think it would be worthwhile if you explain a little bit about the current landscape of blockchain, right? There's different blockchains, there's different layer 2 scaling solutions. So why don't you share a little bit of an overview of the current landscape of the crypto space?
Yeah, totally. So maybe we can start with a little like history, I think blockchain was mostly started around like Bitcoin as kind of the first blockchain that sort of demonstrated the ability around like the distributed ledger technology and kind of like what the promise of decentralized distributed technology gives. And then, of course, that led to Vitalik, kind of, who was a big part of the Bitcoin community, actually creating Ethereum because he wanted to be able to kind of build on top and build a developer platform and a platform where you could run smart contracts, which essentially are a decentralized way to run trustless code. So basically, in a nutshell, there's a lot more we can talk about with that, but don't want to give a whole lesson on that. So then Ethereum kind of demonstrated the viability of a smart contract based platform. And then basically you had this explosion where like everyone was trying to like build on top of what Ethereum did and build different ways of building layer 1. So layer 1 is essentially the consensus mechanism that Ethereum and other blockchains use, which, Bitcoin uses proof of work, Ethereum uses proof of stake now. And then, back in the early days, you had like all these other chains like EOS and, Tron and all these other kinds of chains that tried to like do things slightly different than Ethereum. And you had all this like experimentation at the layer 1 layer. So, for the past like 4 or 5 years now, we've had this like thing where you've had all these different layer 1 systems that have all these different ways to do things. And what's really interesting now is now you've gotten into this place where you have this concept called roll-ups, which is something that has gotten big within the last like, 2-ish, 3-ish years, I guess, where it essentially gives you a way to make another blockchain that is secured by Ethereum itself or any other layer 1. I guess I'll use Ethereum as the example. So Ethereum remains the consensus layer, but then you offload some of the transactions onto these layer 2s, which are roll-ups. So then you have distinct block space that allows you to scale because you're moving the transactions off of the expensive Ethereum layer 1 and rolling them up into these batches of transactions that still get posted to Ethereum, but in a much easier, compressed, cheaper format. So at the end of the day, what you get is you get like the scalability in terms of moving transactions off chain onto these rollups. So long story short, that's how a rollup works. But then now you have like multiple rollups because everyone now is trying to create their own rollups. Then you have like rollup kits, which allow you to build rollups on top of rollups. And now we're at we're at the cusp of this world. We're about to see thousands of rollups, thousands of chains, thousands of like distinct like areas of block space. Because at the end of the day, to a user, a rollup looks no different than like another layer 1 chain. And then you have this problem where you have fragmentation. So you have all these different blockchains that do all these different things, have all these different applications, and then they have their own like liquidity because at the end of the day, blockchains are mostly used to like use assets, move assets around, do different things with like financial instruments. Maybe not all of them are financial, but there will be some aspect of financialization all tied to it. And then that's where you get to this world where everything is like disconnected and fragmented. And then that's where kind of Connext comes into the picture.
Got it. So just to reiterate, There's different layer one blockchains, and these are something like Ethereum, for example. And this allows for the exchange of value, right? Me sending you money and keeping a record of that in a decentralized way. And that's different from a centralized way, like a banking system, for example. But we also, because these are very expensive, you have to pay lots of gas fees. We also have these layer two scaling solutions. One, for example, is Optimism. Optimism allows these transactions to occur, kind of like batch them up, and they occur off the blockchain. And that way it's cheaper, and then they're put on the blockchain. And the security is almost the same, right? There's a little bit of a trade-off of security, but it's almost the same. And that way it becomes more scalable, meaning it's cheaper, more people can use it, and it's faster. Okay, and we have a whole bunch of these different systems. We have different types of L2s, we have different types of L1s, layer 1s and layer 2s. And then we have Connext that are going to help connect these together. So what is, from a very high level, the Connext protocol? What problem is Connext trying to solve?
Yeah, so the problem Connext is trying to solve is the problem that is created by all these individual kind of areas of block space, different chains. So like rollups, like I said, rollups and side chains, layer ones, Cosmos, app chains, all these are different like chains essentially. And I just call them block space because, you know, I don't want to get into the whole thing about like how secure they are. Do they use Ethereum security? Do they use their own security? There's like so many different things. Then you have like data availability on, you know, Celestia, but settlement on Ethereum. You can get into all these weird rollup type constructions that then have like weird definitions of how much of a layer two they are. But in the end, you know, it just goes to show that we're getting in this world where people are experimenting with different ways to scale block space in a way that, you know, experiments has different security mechanisms and guarantees, but at the same time, then fragments the user experience completely. And what Connext is about user experience. So we want to make it easy for developers. At the end of the day, Connext is a developer platform. So what we want to do is we want to enable developers to build experiences on top of these different chains in a way where they don't even realize that they're interacting with different chains. They don't have to understand the mechanism of different chains. They can be completely chain agnostic. And then that all works back to the user. And at the end of the day, the user does not have to worry about any of this stuff. So all of this becomes abstracted at the user experience layer. Connext's always been about user experience. We've pivoted many times along the way, but at the end of the day, our goal has always been, how do we make the user experience of using decentralized technology better?
Got it. So let's just walk through this with a very simple example. So as you mentioned, this is for developers, right, to build applications that allow basically different blockchains to kind of connect to one another, or different L2s to connect to one another. So like what would be, for example, from the user side, a problem that they currently see, and then how would Connext allow the developer to build an application that makes the process simpler? So it's like, what are the main problems people have?
Yeah, totally. So one good example is, let's say you have a application, let's say like it's like Aave on Arbitrum, for example. You have like this protocol Aave that you want to use that allows you to put in your Ethereum and borrow USD stablecoin because you want to like buy a car or something like that, but you want to like hold your Ethereum as collateral. However, you have money on Optimism. And so then what do? How do you like get to this protocol called Aave on Arbitrum? So there's a couple ways you could do it. You can like bridge funds back through the rollup bridge, which takes 7 days to go back to Ethereum on Optimism. And then you have to bridge it back into Arbitrum. And then you have to like use the protocol. So like that requires a lot of transactions. It takes a lot of time, requires a lot of like prior knowledge. So what we have done is we have created this concept called XCall, which allows you to make a transaction on chain A that calls a contract on chain B and sends the funds through. So using like the magic of Connext, you can basically say, okay, I want to interact with this contract Aave on Arbitrum chain, and I want to send this amount of funds through. And then, you know, through the bridging technology and whatever, we can dive more into that later. But like, you know, at the end of the day, your funds will get into this smart contract, and all you did was just send a transaction on Optimism. So at the end of the day, what this can look like and what this allows like developers to build on top is these we call it chain abstraction. So then like your users don't even need to think about what chain they're interacting with, because at the end of the day, then you don't even know that this app is living on Arbitrum, because all you know is you sent this transaction on Optimism and your funds ended up in this position right here. So that's like a easy example. And right now it's maybe a little contrived because, everyone knows Aave, everyone knows Optimism, everyone knows Arbitrum. You kind of like can see what's going on. But at the end of the day, when you have all these thousands of different chains, you have all these applications, maybe you have like a lending protocol that's like a lending protocol specific chain, then, you don't want your users to necessarily think about like bridging funds, doing transactions here. You want it just to be like one click wherever they're at, they're automatically here now. And then they interact with the protocol as if they're just interacting with anything on whatever chain they're on.
Mm-hmm. And that actually brings back a memory I had when I spoke to Nenad, the co-founder of DeFi Saver. One of the services that DeFi Saver provides is it allows people to swap collateral types between different lending protocols. And that sounds, and then one execution, that sounds exactly what likely Connext was the technology that was used to execute that type of transaction.
Well, exactly. I mean, DeFi Saver is like, because I know a lot about DeFi Saver. I've been using them since the get-go, but like, they allow it on the same chain. So they're like, okay, if you have Aave and you want to use Compound, then they'll like flash loan, swap your collateral, put it in. So that is a very similar experience to what we're trying to do, except we're trying to do this like cross chain. So it doesn't matter what chain you're on. And actually, we're working with a company called Fuji that is doing this exact thing across lending protocols. So it will allow you to do collateral swaps powered by Connext across chains.
Got it. Okay, let's just take a step back. You were mentioning the term block space, right? Maybe if you could flesh out what you mean by block space and why you're using this term to describe blockchain space.
Yeah, totally. Because at the end of the day, you want your data, when you're interacting with this technology, you want your data to show up somewhere on some distributed ledger. And when you're talking about a distributed ledger, you mean like a network of nodes that is coming to consensus on the state of things within that particular chain, And then I say block space because you can do this on another layer one. Like, let's say you can do this on Solana, you can do this on Bitcoin, you can do this on Ethereum. And then you get to this concept of rollups. And the weird thing about rollups is because they have their own blocks, but they're not necessarily like coming to consensus on every block, as in like a bunch of nodes around the world are reading every block. Basically, it's all done like through a different system where the blocks are kind of like created locally on this thing called like a sequencer. And then every so often they're posted to Ethereum. So like they're rolled up and it is technically block space, but it's not a blockchain on its own. So layer 2 is not its own blockchain. So that's why I try to make that distinction, because you get into these like I was alluding to earlier, you have these like weird constructions now where you can have settlement on one blockchain, data availability on another blockchain, and then you can have this like roll up. So it ends up making things like really cheap and preserves a lot of the security, maybe not all of the security, but like most of the security of Ethereum at like a very small fraction of the cost. So, that's why I like to say like block space, because, blockchains are a very like specific thing where you have this like blockchain, and then a roll up is like a very specific thing. But at the end of the day, it all just looks like block space.
That's interesting. And I think I should just reiterate here and point out that different blockchains have different trade-offs. So for example, the layer 2 scaling solutions that we were describing earlier, that relies on the security of a layer 1. And that's typically Ethereum, right? Ethereum EVM compatible means blockchains are layer 2 scaling solutions, right? That means they can interact, take advantage of the security of an L1 like Ethereum. But there's also different L1 solutions such as Solana, for example. And Solana tries to solve the problem in a little bit of a different way, right? They don't require L2s because the transactions occur much more quickly, right? That's the way it was designed. But there's also different trade-offs, right? There's less security compared to EVM blockchains or the Ethereum blockchain. So I think at this point it's very clear. There's a whole different bunch of blockchains. There's a whole different bunch of L2 scaling solutions. There's a whole different types of ecosystems of blockchains. For someone who doesn't know a whole lot about blockchain, like in one or two sentences, what is the most important idea about all of these blockchains? Is it that one of them is more secure than the other? Is that one of them's faster than the other? Like big picture here, like what do people need to know about all these blockchains?
Yeah, totally. I think maybe one concept to bring into it would be the blockchain trilemma. So it's like the whole classic problem where you have decentralization, you have security, and you have cost, and those kind of three things are always at odds. And what a trilemma means is basically you can only have like two of those three. So if you look at Ethereum is going for decentralization and security as its two pillars. And what it sacrifices is like the cost/speed angle. And, if you look at Solana is secure because it's like a decentralized system. It's or it is like a system that has this like blockchain properties ingrained, but it's extremely fast and low cost. And what they've sacrificed on is decentralization, which means, and what that looks like, it means that really only like very high powered nodes can actually run the validators. So it basically centralizes the validation power into like a very small number of nodes, but that allows it to do what it does. So essentially, users kind of have to understand where they're fitting into that picture when they're using different blockchains and what values like they care about most. And in my opinion, Ethereum, because it's focused on security and decentralization, is obviously the safest. It's going to be the most secure. It's not going to have downtime. It's not going to do anything like, it's not going to be able to have any like malicious attacks against it. But all of that comes at a higher cost, the cost of using the L1. And then that's when you get in the whole layer 2 thing where you can like remove some of that and you can actually like solve this trilemma by using layer 2s that preserve the security while still giving you that speed and cost. But then you get into the whole fragmentation issue, and that's where we're back at this whole thing.
Yeah. Okay. So let's dive into Connext in a little bit more detail. So we talked briefly about some of the use cases, but I think we should flesh them out in a little bit more detail. So some of them, right, I'm just quoting the website here, include an any-to-any swap. There's X-chain lending. There's cross-chain NFTs, X-chain staking, and others. So maybe if you could choose one or two of your favorite use cases here and explain them in a little bit more detail.
Yeah, totally. So like, I think the any-to-any swap might be a good use case because it's easy to kind of wrap your head around. But basically the idea is, let's say you have what's a good example? Polygon, right? So you have Polygon as its own separate L1. Polygon like POS chain is not an L2, it's an L1. So it's its own set of validators that controls its own chain. And say you have ARB tokens on Arbitrum, and you want to do something on Polygon that requires Matic tokens on Polygon. So what Connext enables is an any-to-any swap, which means that you would swap your Arbitrum tokens into something that gets bridged to Polygon, and then those tokens again get swapped through the mechanism on some decentralized exchange on Polygon, and then they get swapped into the Matic tokens on Polygon. So essentially it's like a swap bridge swap. That's what any-to-any swap means. So you're going from any asset on any chain to any asset on any other chain. And that whole process, I mean, maybe I can back up a little bit and say that in a nutshell, all of this is enabled by this primitive that Connext has created called xcall. So this allows you to send any data across chains with any asset across chains, or not any asset. I will say any asset that is able to be bridged. So let's say you want to send, since you can bridge Ethereum is basically like a base asset that can always be bridged. So you can send any amount of Ethereum with any data. So basically you would send the data that allows you to do a swap on a DEX through the mechanism of the bridge, and that would hit the other chain, and then it would execute that data. So it's essentially a cross-chain contract call. So you can call any contract on any chain. And since the DEX is just a smart contract, we could just send the data. We could package up, we could generate all the data that we need to do that swap on chain A, send it at that time, and then when it hits chain B, it gets executed.
Now, you mentioned the term any data. So does that imply there's additional information that's being sent over? Like, what do you mean by that?
Yeah, so basically what I mean, it is additional information sent over. There's like a field in the XCall called call data. So that means that is data that gets executed. So what you do is getting a little technical here, but you encode the exact data that is required to call that smart contract on the destination chain on the origin chain. So that gets basically determined and generated upfront on the origin chain, but it doesn't get executed till it hits the destination chain, and the mechanisms of the bridge ensure that it's the exact same data that gets sent, that gets received, and gets executed on chain B. So you kind of have this like trustless mechanism to know that you are actually calling a smart contract on chain B and tell it what you want to call on chain A.
Okay, so one of the things that Connext promotes is the idea of not introducing any new trust assumptions or external validators, right? And I assume that's different from other bridging services or infrastructure protocols that allow applications to be built that can connect L2 solutions. So what do you mean by it doesn't introduce any new trust assumptions? I know there was 2 billion worth of hacks in bridges in 2022, right? So we could talk about security in a little bit more detail after. So what are these trust assumptions about?
Yeah, totally. So, okay. So when you're bridging from one chain to another chain, you're not actually like sending, like there's nothing actually like being sent or received. It's not like data is like getting from one place to another place. Like what you're doing is somebody is looking at data on one chain and saying that it's okay to do that same thing on another chain. So the easiest way for that to work is you have like a centralized actor. So there's just like some server, or it could be even like some person who's just like watching this address and saying, okay, if funds go to this address, that means I can send funds on this address because they're like locked in this address. So that would be like the most trusted way to do something. Then you can expand on that and be like, okay, well now I'm gonna do like a multi-sig. So like these 5 people are going to all validate that this transaction happened on this chain, so I can allow this transaction to happen on this chain. And a very easy way would be like, okay, if tokens are burned on chain A, then I will mint them on chain B. That's like the easiest example of how do you transfer tokens from one chain to another chain. You burn on this chain, you mint on this chain. Burn on this chain, you mint on this chain. So that's the easiest example. And then it always just relies on somebody to actually validate that that is what's happening. So then you get into the multi-sig concept. And most bridges, they just stop here. They're like, okay, we're going to be a multi-sig. We're going to watch this chain. We're going to have this set of actors, watch this chain, and then execute things on the other chain. So that's the external trust assumption, because at that point, you are trusting this external party, small set of validators, to validate that transactions from this chain are correct and are valid on this other chain. And that's where a lot of the bridge hacks, you talked about bridge hacks, a lot of them have happened because, enough of these keys get compromised where this validator set is no longer valid. And now the validators can do whatever they want. So they can mint as many tokens as they want on chain B and basically make your chain A tokens worthless, because the whole idea is these tokens are worth something because they are backed by funds that have been burned or locked on the initial chain. So then we get into this whole concept around like, what is a more trustless way to do this? And then you get into this whole concept around rollups and rollup bridges. So rollup bridges are basically the most trustless way to send funds between a rollup and a layer 2 and a layer 1. So basically when you're sending funds from a layer 1 to a layer 2, like Ethereum to Optimism, you're depositing it into a smart contract on Ethereum, and then that's getting to Optimism. So then you don't have any trust assumptions. You're just trusting smart contracts at that point. So that is the ultimate way of bridging funds. But this only works between like Ethereum and the layer 2s. So what Connext does, I mean, I won't go too much into detail about this, but Connext uses these canonical bridges, which are the roll-up bridges, wherever it can. So it will take the most secure route between any two paths. So it will offload the security of the system instead of like inserting its own validators. It will use these bridges to actually like bridge the funds through and bridge the messages through these like very secure, highly secure paths. And additionally, in the case of something like Polygon, Polygon has a system where all of the validators on the Polygon chain validate the bridge itself. So Polygon has a bridge between Polygon and Ethereum that is validated by the proof of stake validators themselves. So in this case, this is a secure bridge because the validators of you trust the chain itself because all the validators of the chain are the validators of the bridge. So in that case, we can also use that bridge as another path. So Connext, when it's going from Polygon, let's say, to Optimism, it will go Polygon to Ethereum through that ultra secure bridge, then Ethereum to Optimism through that ultra secure bridge. And that way, you're not providing any extra trust assumptions because you're only trusting those bridges, which you're already trusting anyways. And there's no like Connext validators and things like that are in the middle.
Great. Okay, so just taking advantage of existing infrastructure that exists between L1s and L2s within the same ecosystems. Makes sense.
Exactly.
Okay, so let's talk about being a validator for Connext.
There's no like validators on the Connext protocol because the Connext protocol itself does not have its own security. Like it offloads the security to the bridges underneath. However, you know, this is a detail I didn't really hit on in the initial explanation. So when I'm talking about like, you know, going from Polygon to Optimism, you're going to take this like, you're going to send these messages through the bridge from Polygon to Ethereum and then from Ethereum to Optimism. However, this takes a really long time, right? Because what we do is we batch a bunch of transactions into like a Merkle route. This Merkle route then goes through the Polygon bridge, which can take like 2-3 hours. And then it'll go through the Optimism bridge, which can take like 15-30 minutes. And then at the end of the day, then it gets to the other side. But in the meantime, what we have is we have this decentralized network of liquidity providers that can come in and like instantly fill an order. So they can like upfront fill the order for the user on the destination chain and they will get paid back by the slow path. So essentially they're taking like a, 2-3 hour delay to get their funds back for a small fee that they get for providing the liquidity very quickly. So that allows us to insert these ultra secure systems underneath and not worry about how long they take because, speed, gets back to that whole like speed cost trilemma thing, speed, security trilemma. So, we've solved that trilemma kind of by having this decentralized network of liquidity providers that will take the basically the slow path while they provide the fast path and they get a small fee for doing that. That exactly is where the like decentralized network of liquidity providers and they're kind of like, we refer to them as like routers. So they're not exactly validators, but they are a decentralized network of actors that do participate in our system.
Okay, so let's just break that down a little bit. So we have these people who are providing liquidity, right? They're providing their funds so that people can more quickly transfer funds between different blockchains. I'm aware that you need to put a lot of funds up front. We're talking about $100,000 to $500,000, if I've read the website correctly. So could you speak to like why this is actually such a high threshold for people to become liquidity providers?
That is it's only because of the phase that Connext is in. There's no real reason for that to be the case. The only reason is because initially when we onboard these routers, we wanted them to be like, people that can highly support the network with a small amount of actors in order to kind of like bootstrap the network while we are in a stage where things are still quite new and we might need to be like, oh, you guys need to update your software to like support new things. We need to like kind of like make these optimizations and improvements. So we wanted people that kind of like we can really like trust to provide a good experience for the users. At the end of the day, they can't do anything. They can't rug users or anything, but they could just like be MIA and force users to wait the slow path. Because, you know, another thing is like, if there is no liquidity, if there is no like router available to like front the transaction, then the user just has to wait and they will get their funds eventually. So at the end of the day, that's always the fallback option. But, you know, we want to provide the best user experience. So we want these routers to be here. We want there to be enough money in the system so that users consistently have a good experience. But, you know, we've also designed the system so that you can split value across many routers. So you can have like a, you know, $10,000 transaction where each router has $1,000 and split it across 10 routers. And we've designed this in a way so that like smaller routers are able to be supported. And, you know, now that Connext is live with the DAO, the token is launched, and now things are going to get more and more decentralized. We are planning very soon to like open up that and allow permissionless routing, liquidity provision.
Got it. Okay. So this reminds me of invoice factoring a little bit. I just recently had Adam Blumberg from the Interaxis YouTube channel. It's a great YouTube channel to learn about the crypto space. And he was explaining how invoice factoring is very, very similar idea actually to how the protocol leverages the same idea with the liquidity providers. Okay. So I just want to talk about the token now briefly. First, I'll share my thoughts for a brief moment. So I don't, for example, like to see tokens as much like on CoinMarketCap and then having a token, or rather a project associated with that token. I don't think it's going to be what the future of the crypto space looks like. I think likely what we're going to see is more projects that are simply just like able to facilitate DeFi related transactions, just like in its own way. And it doesn't need a token to bootstrap the project. It doesn't need a token to basically have people earn crazy APYs in order to like people have stuff locked into the protocol. Like I don't think that these are great ideas necessarily. Not that I have solutions, but I mean, just overall, I think we're going to move away from this trend. So I know the next token, right, the token for Connext, was just recently launched. So I'm wondering if you could speak to maybe your thoughts on tokens. I know that the Connext team, if I recall correctly, has a little bit of a different perspective on tokens and governance tokens associated with projects. So why don't you share your thoughts on it?
Yeah, totally. So I think there's a couple few things at play here. You know, I think I agree with you to some extent that there are a lot of tokens that don't need to exist. There are a lot of tokens, you know, because people just see the opportunity to kind of like extract value so they can launch a token and do that. However, I think one important distinction to make is that Connext is not a company. It's not trying to be a company. Connext is a public good. So Connext is trying to build infrastructure that provides public infrastructure to people that anybody can use, anybody can participate in, and will just work in a decentralized way forever. Like Connext doesn't even need to be around for the Connext protocol to exist and the company and the project to like keep going. The company does not need to exist. There is no company behind Connext. Like there is a labs entity and there's a foundation, but the labs is just like providing services to help build the protocol and provide services to the DAO. But if labs entity went away, the protocol still exists and everything like runs itself. And in that scenario, I think a token is important because you need some kind of aspect of governance and you need some kind of like way to kind of govern the protocol and allow mechanisms for people who care enough about the protocol to get involved with it. So I think, you know, there is this like weird line of Connext doesn't take a protocol fee. There's no fees on the bridge that are actually coming back to Connext, you know, because I think you get into like you're alluding to, you get into these weird situations where you have these tokens where the protocol is taking a fee and like, you know, they're returning tokens, they're returning value back to the token holders because there is some fee. Because then you get into this weird situation where you're like, okay, well, I could just like fork the protocol, remove the fee, and then it's just like there is a public good. And, you know, that's kind of the situation that Connext is already in. There's no fee. There's no like value capture coming back. There's no like, oh, you stake the Connext token, you get some like return from the bridge fees. You know, that would be like cool for Connext to do, I guess, now. But like what we see that being a race to the bottom because we don't see that as a sustainable way for Connext to be in the long term. Because I think you do get this you get this situation where everyone is then competing and the fees are kind of like racing down to zero. So we're like, why not just start with a zero fee protocol to begin with? Because everything is going to get there eventually. And then the token has a different value where it becomes like actually a method for governance by the actors that actually like care about the protocol and those who want to be involved. And, you know, to your point, I think it's, you know, you can say what you want to say about token governance and things like that. And, you know, it's not the best system. Of course, it like, you know, favors whales and has all these weird games and there's a lot of weirdness going on, sure. But I think at the end of the day, Connext wants to operate as a decentralized protocol. We don't want to operate as a normal company where we're like trying to make revenue and, you know, our bottom line every month. We're like focusing on our like P&L and stuff like that. Like Connext is not structured that way. Like we don't want to compare ourselves to a Google or a Tesla. We want to be more like an Ethereum, you know, like that's the scale we want to get to. Like if you think about Ethereum has a token. Ethereum does not have a revenue generation scheme to the token itself. I mean, it has staking now, but there's no like centralized entity that is taking part of the fee and, you know, collecting the fees and dealing with that. It's complete public good. Like it just exists and it works because of the token. The token is a big part of how it works. And, I think, you know, eventually that's where we want to get to with Connext.
Okay. That's interesting. I think it's a great ambition to have, right? Something that's here to stay in the long run. We see too often projects that are there in the short run and then end up, you know, not being sustainable for whatever reason. But I do want to push back on an idea you presented, the idea that, okay, you build the infrastructure and then you kind of back away because it's decentralized, no one controls it. Because, you know, one of the things that I've learned is that there's different versions of protocols that are released. Things change very quickly in the crypto space, right? Just looking at L2s, for example, it's really changed the way that the overall space has been designed. And we explored that a little bit earlier. So if it is true that there doesn't need to, like, per se, there can be governance involved, yes. But I mean, is it not true that if you don't have like more of like a centralized team working on it, the project will just become outdated because the space continues to evolve?
Yeah, I think that's totally a great point. And I think I didn't necessarily mean that like nobody should work on it and it should just like exist. But what I meant is like, you know, you don't need that like one company or person to be pushing it. And it's, again, you know, I'll come back to like Ethereum and look at Ethereum in the same context. It's like if you look at Ethereum, there's a completely organic group of external actors and teams that are all contributing towards this, and nobody like hired them to do it. They're just like doing it because they want to, and like doing it because like, you know, they're like a client team like Prismatic or someone like that is just like, oh, they're going to build a client. They're going to just build this out of a public good. They're just doing it out of like goodness of their heart. Sure, they got like grants and stuff like that, but like they just wanted to build on top of the protocol. So, and that's the position Connext is in too. So right now we have about 4 or 5 core teams that we're calling that are all contributing independently to the Connext protocol. And that's how we want to structure it. So we don't want like us who are like the founders of the protocol to be like in control of everything and kind of like dictatorship, like leading things. We want to bring in the smartest people who care about advancing the protocol. And yeah, we want to advance the protocol. We don't want to get like left behind and outdated. We want really smart teams, really good people who really see the vision and see the kind of like end goal of where we're trying to get to and help us get there by contributing as much as they can. And, you know, their contributions are so much so that like the Connext itself, our original contributions are kind of like, you know, I'm not going to say like meaningless because of course like Connext cares enough to like to advance the protocol where we're going to be the ones carrying the torch and like showing people what we need to do. But like, you know, if we didn't do that, somebody else would step in because they have enough interest and ability.
Okay, so I want to talk about a little bit of a different idea. This is something I believe I recall you spoke about on a previous podcast you participated in, but I recall that you said that the community of people who are building within the space is quite small. So I believe there's a lot of conversations being held with founders of different projects to try to bring the space forward. So I'm wondering if you could speak to what people at the highest level who are building Optimism, Arbitrum, Ethereum, and so on, what are they thinking in terms of the future of the space? And I don't mean necessarily from a technical perspective, but I mean like where are people's hearts in terms of the future of the space? Like, where do they want things to go as opposed to where they might be going technically?
Yeah, it's a really interesting question, and it's kind of hard to say because obviously I can't read their minds, but I think it's gonna vary depending on like which one of those you want to zoom in on. If you're looking at Ethereum, Ethereum has a roadmap. They have like Vitalik, who's been like a great good. I think in that case, it's like, if Vitalik wasn't around, like, yeah, the protocol would still go on, but it would like lose a huge figure in terms of like, the leadership and the kind of like overall vision. And, Vitalik is really like completely like pro decentralization. He has the values. He wants to like make this a sustainable thing that will be around forever, you know? But then you get into people like Arbitrum, Optimism. I think those two in particular have a very interesting situation because they share the ideals of Ethereum in the sense that like, they want to build decentralized technology. They want to, further the space, but they are very much competing with each other. And like, they very much want to win. So like, they are in this like kind of like war with each other where they're building things that are basically trying to like lock people into their ecosystem. So they're like going on two different paths and kind of like building the same things to some extent, but they're like trying to basically lock everyone into their system. Like Optimism has the OP stack and they're trying to basically like get as many people to build on the OP stack as possible. Arbitrum has like the Orbit stack or whatever. So they're trying to get as many people as possible. And the interesting thing is if people only use the OP stack, then you would have this situation where everything is interoperable with each other off the bat. You don't even need something like Connext. But then you have Arbitrum who's doing their own thing. Then you have like Polygon who's doing their own thing in the ZK world. You have ZK Sync who's doing their own thing. So all these people are doing their own things. They're of course trying to like, I think for the user at the end of the day, it's going to always get better because they're always trying to build the best tech and build the best product, but they're all kind of trying to like win at the end of the day. So, that's kind of why you get into this world where they all have these different standards. They're not going to ever agree on one like full standard that like makes all the rollups interoperable with each other. And that's where you end up needing something like Connext to like basically bridge that gap between them. So, I'm not fully sure if that answered the question, but I think it is an interesting point to bring up.
No, I appreciate you bringing up that point. On the point of Connext, actually, the Connext protocol has been very successful, I would say, in not necessarily convincing, but persuading some leaders in the industry, founders, as well as venture firms about the project. I know there's been a recent raise. I know that the project has a quite large valuation. I read this, I believe, on Yahoo Finance quite recently. So I'm wondering if you could speak to, again, how Connext has been successful in building this product. I want to learn a little bit more about the success it's had and how it's continued to succeed in facing challenges time and time again, innovating and so on.
Yeah, totally. I think a lot of this comes down to like the legitimacy and the kind of respect that Connext has been building and the goodwill that we've been building in the space for a long time. Like I said, we've been around over 6 years. Arjun, myself, and our other co-founder Lane have been basically in the conversations with the earliest people in the space since 2017. We showed up at all the conferences. We've been around. We've talked to everyone. We know like everyone who's building the space. And because of that, we've gained some aspect of legitimacy around that. And because we've consistently shown our values, we've shown that we've done the right things. Like we haven't basically like sold out, I guess you would say. Like, in the bridging space, like I alluded to earlier, there's an easy way to do things where you just use like a multi-sig and you use a very centralized system and it works really well. It's really cheap. It works great. Like, it works while it works. Of course, then you get to a point where you could get hacked or whatever, and then it doesn't work anymore. But, a lot of companies and protocols will take that risk because it's easier. It's easier to grow. It's easier to gain market share. It's easier to get users. It's easier to kind of like fake it until you make it, basically. And Connext has never done that. And I think we've always pursued the hard path. We've always stuck to the values, and we've always, and because we've been so passionately speaking about this, like certain people like recognize that. And like we won't get everyone to recognize that, but we will get the right people to recognize that. And then that includes like the VCs and the backers who have kind of like been with us along the way because they like believe in the vision and they believe in the end goal and they believe that we will succeed just because of like the amount of like passion and the values, and the fact that we've never like reneged on these values like makes it so we are, viewed in this kind of light.
Yeah, that's great. That's great to hear. I mean, the more consistency you have, I mean, just build a reputation. That's wonderful.
Exactly. And sorry, along those lines too, it's like, since we've been around for so long, we've been through like multiple bear markets. Like literally it's been crazy over the past 6 years. We've almost died 2 or 3 times where we literally were like on our like last months of funding and like, like had to like cut everyone's salary and like, had to basically like just go into what we called cockroach mode. We've done that like 3 times now, or literally it's just like whatever it takes to survive. And we've always gotten kind of like lucky / bailed out / talked to the right people at the right time, and like ended up like, raising a little bit of money to be able to continue at the right time, or like hitting the right part of like the bull market turns around at the right time, and we're like able to kind of like talk to the right people and get the right money, until we got to the point of like the last raise, which is like a big raise where we kind of like we're at, we'd shown enough legitimacy. We'd shown that we'd continued shipping, we continued working, we continued our dedication to this project enough to like, to have people that really believed in us enough to put themselves on the line for us, I guess.
Yeah, that's awesome. I mean, it's great to see. I mean, again, it was a pleasure to do some research and learn more about the Connext protocol. Okay, so let's talk about Connext in a little bit more detail. So bridges and allowing applications to be built. This is not simple, right? This is a lot of computer science. This is a lot of programming. And this is something that most people, if not almost all people, don't really understand, including myself very intimately, as someone who's learning to do a lot more programming in Python. I haven't jumped into Rust or Solidity yet. I still have my own way to go in really understanding the building blocks of what makes up Web3 and what makes up blockchain. And so I think this would be a good opportunity, at least for a few minutes, to just jump into some of the technicals, right? Let's really break down what's going on here from a technical level. I know you're a co-founder, but you're also the CTO, right? So you have the background, you have the knowledge base to really explore this topic. So I'll let you just, as you would choose, explain from a technical perspective how Connext works.
Yeah, totally. So there's a few different mechanisms at play here. So basically Connext consists of 2 parts. We consist of the slow path and the fast path. So that's what I'll say. So the slow path, like I alluded to earlier, is the path that deals with like the slow bridges and the secure layer of messaging that propagates messages through the different bridges. So the way Connext is set up, it's a hub and spoke model. So you have Ethereum layer 1 as the hub, and everything else that's connected to Ethereum is the spokes. And when you want to go from, say, chain A to chain B, it's like a spoke, hub, spoke interaction. So what that looks like on the technical side is we have a bunch of we have relayers essentially, which are these actors that are basically watching the chain. We have, first of all, before that, we have a set of smart contracts. So smart contracts sit on every spoke and the hub. So what the smart contracts do, every time somebody makes a transaction on chain A, it aggregates all the info of that transaction into a hash, and then it hashes that with everyone else's transaction into a thing called a Merkle tree, which has a root. So not sure how technical you want me to get with that, but a Merkle tree is basically a representation of a bunch of data into like one 32-byte root. So basically you can represent all this data into like one very small bit of data. And then you can prove that anything in this tree exists within that tree. So it's like a really cool thing. Basically, like that's what makes blockchains work essentially, is like you have a big piece of data, or you can prove any piece of data lives within this really small Merkle root. So then this Merkle root gets aggregated on the spoke. And then every so often, like every 30 minutes, or I think we set it at 30 minutes, we send this root from the spoke to the hub. And then we use whatever bridge mechanism is there within that path. So let's say Polygon, we'd say, okay, send this root, the latest root, through this Polygon bridge. Then that happens, and then it arrives on the hub. And then the hub has its own Merkle root where it aggregates. So once this root arrives on Polygon, then it gets aggregated with every other spoke. So every other spoke is also sending their root to Ethereum. And then all those get aggregated into one more Merkle tree. And then that Merkle root gets sent back to every other spoke. So then once that arrives, now you have basically all the data from every spoke on that spoke. So now you can take all the data that from the chain that where you originally sent it, and you can prove that that data actually exists within this Merkle root. So then that allows you to say, okay, so somebody on chain A actually requested that this happen on chain B. And you can just do that all with these Merkle proofs. And it's really cool to see, but basically that gives you the data availability you need to be able to prove any transaction happened on chain A, on chain B, through this basically batching of Merkle roots. It's basically a two-layer Merkle root. So you have a Merkle root from the spoke, and then you have a Merkle root of all the spokes on the hub that gets then propagated back to all the spokes. So that's the slow path. And that's mostly smart contracts. And there are like a couple layers of like relayers. So then you have then on top of that, you have the fast path. So the fast path is basically, this is mostly off-chain code. So this is mostly these routers, which are, off-chain agents that are basically bots that are then looking for transactions that happen on spokes. And they are executing the result of that transaction on the other spoke. And they are basically like executing it in a way where they know that they will get paid back. Because if they don't execute it properly, they're not going to get paid back and they're just losing money. So they are incentivized to run the proper computation and send the proper amount of funds and everything like that. Because if they don't do it exactly right, they're not going to get paid back. So
Okay.
in a nutshell, that's how it works.
Okay, great. Yeah, thank you for laying that out. I just want to point out, you mentioned a key word there, which is that these Merkle roots and Merkle trees are fundamental to blockchain technology. So I recall reading Mastering Bitcoin, right? It pretty much takes a chapter or half a chapter to explain what Merkle roots are and Merkle trees are, right? Again, using a small piece of information to prove a larger piece of information that exists. And again, this is an idea I'm not going to try to reiterate, right? I think you did a pretty good job laying that out. But I would encourage our listeners, if they're interested in learning more about how this technology works more technically, Mastering Bitcoin is a great starting point. I found that to be very useful in understanding some of the fundamentals that then are built upon, such as in the case of Connext, to make it a little bit more of a sophisticated process.
Yeah, hashes, I think are the first fundamental thing. Hashes and Merkle trees are like amazing concepts. Like, when I first learned about them like 5-6 years ago, I was like mind blown. Because it's like you can take any amount of data, run a hash function, and it turns into like this small little compact hash that's always the same size. And no matter what, you can never generate that same hash unless you put in that same data. And that's like key to blockchains. It's like basically what makes blockchains work.
Yep, and different types of hashes and a whole bunch of other pieces involved. I'm look forward to continuing my education on the technical side in the next year of how this works. Okay, so last question for today, Rahul. I'm wondering if there's anything else you would like to share. I know there was this recent airdrop. I believe there's some other things lined up, but what's the future of the protocol look like? Anything exciting you'd like to share?
Yeah, totally. So, I think this is just the first step. We're just getting started. So there's some really important protocol upgrades that are happening on Connext, which will allow us to scale out. I think, right now Connext is connected to 6 chains. It's basically like a proof of concept. This is not at all what we see as the end goal for Connext. Like I was been alluding to since the start, I think we're on the cusp of seeing thousands of chains. And, you know, when I say chains, I mean block space. Get back to the original conversation, because they might not all be chains. They'll all be like little app rollups, but they will be siloed areas of block space that are fragmented from each other. And they're literally 20 protocols, I think, that are building these roll-up kits that allow you to build roll-ups on top of roll-ups. So like, you know, the whole space is moving towards everything needs to be like a self-contained roll-up. So that is going to be a very complicated world for users to navigate. And we're going to need a lot of tooling to make this anywhere close to like a level of user experience that is acceptable. Like if you think about like the Web 2 world has amazing user experience these days. Like blockchains have been around for like the past, I don't know, 10 years or whatever. That 10 years of time that has also gone into making like Web 2 more usable is like insane. Like the amount of like the polish that goes into things like, you know, Apple Pay or like sign in with Apple and like, you know, iCloud and things like that. It's just like insane. And that's the level of user experience we need. And the problem is we're just complicating it more and more with these like scaling solutions and extra blockchains. I mean, I'm not going to like talk too much about this, but I do think it's a bit of a premature optimization to get into like real crazy app chains right now. And we're like, we don't even have enough applications to like demand that kind of block space, but you know, we are going there anyway. And that's I think the really important piece of the puzzle that Connext is going to try to solve over the next like, you know, 6 months, year, 2 years, is how do we make this as seamless as possible for the user? Because things are only going to get more complicated, and they're already complicated as is. So yep, that's a little sneak peek of the future, I think, and that's where we're headed.
Yes, I would say that things tend to become more complicated with time. The more I study any subject, it grows more complicated, not more simple, that's for sure.
Exactly.
Rahul, thanks so much for joining me on the podcast today. It was an absolute pleasure to learn more about Connext, your role at Connext, and a whole bunch of other things about the crypto space.
Thank you so much. I had a great time. Thanks a lot for having me, Ari.
Thank you for listening to this episode of the Ari Kim podcast. Please consider supporting it through the Make a Contribution button or the wallet address found in the video's description.